Okay, pause and copy. What are we saying here? We have two non-zero vectors, u and v, in R3. So this is the origin. Perhaps we have u going like this, and then v going like, let's make it a bit longer, v, like so. And then the angle between them, the smaller angle between them, which is this one. Now you have a parallelogram determined by these two. Well, that is the obvious thing. You do this, and you have an area of this thing here. Okay, so what are we saying? We're saying two things in part one. Let's break that up into part. We'll call this A, we'll call this B. Now, to sketch a proof here, we'll start with A. Now, how is this established, this equal sign here? Well, I'm going to cheat a little bit. I'm going to say, well, we have something called Lagrange's identity. Now, the proof of this, I would say brute force. It's not very pleasant. It's an exercise in the textbook. What you do is you say, u is equal to u1, u2, u3. V is equal to v1, v2, v3. And you work out both sides of this equation. And it takes you a while, but you see that they're the same. Okay, so we're not going to do that. We'll just take Lagrange's identity as given. And then we will take this u dot v and write it in its other form where you have the cosine theta. So from here we get u cross v squared is blah blah squared v squared minus length of u times length of v cosine of the angle between them. Now what happens, I can factor out this quantity right here. Squared, squared, factor that out, and I get 1 minus cos squared theta. And what is 1 minus cos squared? That is exactly sine squared. So we are very close now. Square root both sides. Is equal to u v. And you actually get the absolute value. If you think about it, you get the absolute value of sine theta, because if you square something and then square root, that's the same thing as absolute value. But we're assuming that theta is the smaller angle between u and v. So this angle theta will be between 0 and pi. So it's positive. So the absolute value can be dropped. Okay, so there's our formula. There's our part A proven. Okay, we've established this equal sign here. Now the second one, for part B, what I'm going to do is just say the area. What is the area of a parallelogram? Well, it's going to be base times height. area equals base times height. And that is this quantity is our height. This quantity is our base. So the base is the length of V. And then if I think about the I think about sine of theta. Sine of theta, looking at this triangle here, is opposite over hypotenuse. So H is U sine theta. So area being base times height is this times this, exactly as we want. Okay, so that's the part one of the theorem. Now, part two, we've seen this before in terms of determinants, but you can see why it's true as well just by focusing on this equal sign here. So I'll just leave that alone, and I will move on to the example. How do I find the area of a triangle in R3? Well, let's just draw something to help us think. So we have this triangle PQR. I want to find the area. Well, what we're going to do is we're going to say, well, this area, what is it? Well, it's half the area of something we can find easily. We can, if we look at this vector and this vector, we'll say U, we'll say V. Then from the theorem we just looked at, the parallelogram determined by U and V is this one. So we could say area I want equals 1/2 area of parallelogram determined by U and V. Oh boy. So that's a half times the length of U cross V. Now, as I've drawn it over here, U is PQ. Cross PR. And I can find PQ and PR by subtraction. So PQ, so I do what I do, I go Q minus P, right? So I get 1, and I get a minus 2, and a 1. And then PR is R minus P, so minus 1, and a minus 1, and a 1. Okay, focusing here, half the determinant I, J, K, 1 minus 2, 1, minus 1, minus 1, 1, which is half. Negative 2 plus 1 is negative 1. Oh, I need something. Oh, I screwed up. I forgot my length thingies. So I need these length things here and here. Okay, where was I? Finding this cross product still. So looking here, this number, this determinant will end up here. -2 plus 1, and then this determinant, which is 1 plus 1 is 2, minus 2 here. And finally, this determinant will go here. What's that? -1 minus 2 is minus 3. 9 plus 1. Yes, this looks good. So I get a half square root of 1 plus 4 plus 9. So that's 1/2 root 14.